All right, good morning. Welcome in for another Friday Safety Focus of the week. It is June 30th, the last day of quarter two. Good time to take a little halftime break over this weekend, and if ones are taking Monday off. This code of conduct this week is to work to OSHA, FR, and ECI safety standards, the safety department's favorite code item. Good reminder to follow all the standards that we have set forth. And if there's any question on a standard, please contact us and we'll get that resolved by looking it up in the OSHA book. Next slide, Austin.
There you go.
So safety news, good job this last week. Another 7 days tagged on to our statistics. We're up to 58 days from our last recordable. And it's been 14 days from our last first aid injury. So let's start today off with a good JHA. Communicate those hazards, mitigate the risk out there, work safe going into the weekend. With that said, Austin, I'll pass it over to you for housekeeping. And it's a big initiative. The safety committee met on Monday, and we're going to try to push out a lot more about housekeeping and having really clean and organized job sites. And it's actually great that we're highlighting the Royalton job because that's a really great example of a clean and organized job site, as you'll also see in the photos today. Take it away.
All right. So I'm going to talk about housekeeping. We've been going around and all the job sites, pretty much look pretty good. But there is just occasionally, you see some trash or, stuff when you're tearing down materials, things like that gets, set in walkways, things like that. You see people stepping over it, and those can create tripping hazards. So, the first thing here, tripping over loose objects on the floor, the stairs, the platform, your walk areas, wherever you're walking and working. If it's dirty, you can have, falling objects come down that are just sitting up on scaffold. I've seen some situations where there's a 2 foot cutoff of a 2x4 just precariously sitting on a scaffold and waiting to fall. So things like that, just pick things up when you go by them like that. And they can create greasy, wet, dirty surfaces that you slip on. If you got a pile of materials that's not well organized or out of the way, you could run into it. If you got a piece of rebar or something sticking out from a pile, you can slip and trip into that, things like that. And then if you have to dig around looking for something, you can, injure your hands, cut your hands or other body parts as you're trying to find something. So some benefits of good housekeeping are there's less need to handle materials. You're not, picking things up, moving it, looking for something. Obviously fewer slipping and tripping hazards and accidents. And then fire hazards are decreased. You don't have piles of trash and things like that can, get a spark in them and catch on fire. If you keep sweep and all that, if you got areas that need sweeping, it will lower the dust and vapors that accumulate. And you'll just have more use of the space available. We've all seen it. You have a dirty room or something like that, and you're like, oh man, it's awful. I can't do anything in here. You clean it up, and you're like, wow, I have so much more room to do things. So, and looking for tools and materials are easier to find when they're just kind of like thrown in a job trailer or something like that. Someone asks, "Oh, can you come go grab this out of the trailer?" And you search around for a half hour for it instead of just going to where it should be, grabbing it, and coming out. And that improves the morale and productivity. If you can't find something, you're gonna get pretty frustrated, and it just everybody is in better spirits when job sites are clean. It's easy to find things. And you're not going to work being like, oh man, it's a mess. Here we go. Another day looking for something. Um, so implementing an effective program, clean up during your shift. It's a lot easier to clean up small mess of things than letting things accumulate and become a bigger issue, and just something that's gonna take a long time to pick up. Day-to-day cleanup, just like I said, as you're walking around, if you see something laying on the ground that shouldn't be there, just pick it up on your way, to doing something else. Or at the end of the week, spend an hour at the end of the week cleaning up the job site, make things look neat. And then have good trash disposal, and remove any unused materials. If you have something that's been sitting around for a week and you're not going to use it, bring it back to the yard, put it somewhere away where it's not going to be in the way of your work. Also, I want to talk about with the holiday weekend coming up, a little bit of locking up your trailers. If you can't bring them back to the yard or something, like gonna have to stay at the job site. Put a piece of machinery near them where they can't just be towed out of there. Things like that. Lock up, compactors. Lock up all the equipment. Just secure the job site so nothing can have to happen to it this weekend. So that's all I really have.
Thanks,
Okay,
Austin.
thanks. I'll take over the screen now.
Take it away.
I will say too that, like Matt's comment about Royalton, when a site is nice and clean, a lot of people notice, and they notice when it's dirty too.
Yeah, that is very
And
true.
disorganized. Okay, Windows, just pulling up my email of the week. There we go. Can you see my screen?
We got it.
Okay. Okay, for announcements this week, of course, it's Independence Day holiday. So happy Independence Day, everybody. That's Tuesday. So ECI's offices are closed, but several projects will be shut down on the Monday holiday. So check with your supervisor. Time records are going to be really important this coming week because of the holiday in the middle of the week. So we ask that you get your time records in at the end of today. And a special effort is needed because what normally happens on every Monday morning is that there's a whole bunch of missing information and incomplete, and it's not too bad, but it's a pain, but it's not too bad to reconcile because Monday morning everyone's typically around, but we need to process the payroll this Monday. And if you happen to be off because your crews are off, your project is recognizing the third as a day off, then you may not be available to answer the questions about how your time was recorded and whether it was done correctly. So take the extra time right now, the extra special effort when you do your time cards, records later today. Just go back through and make sure you're complete. Make sure you got full days, full 8-hour days, at least 8-hour days, obviously, and make sure you got every day covered. So that's always a big thing at for the payroll processing. And of course, like Austin said, secure your job site. Holiday weekends are historically the worst for theft and vandalism. And secure your job site for potential hazards to the traveling public. And erosion or flooding or anything, I don't think there's any severe weather expected. I think it's kind of the same as it has been. So just a follow up on next announcement is a follow up on the ECI retirement plan. The migration has been completed from Newport to a census. So you can now log into the census portal with your Newport login credentials. And when you go on to the census website, look for the link to the Newport accounts, and it'll set you up. I know when I checked mine online earlier this week, it still worked on the old login for Newport, and then I couldn't figure out how to get onto the census with the same login credentials, but I had to go and click on the from the census web portal, the Newport account link, and everything seems to work great. Everything seems there. And next announcement is at Morgan Stanley Financial Advisors. About them, they are our kind of our counselor, I'll say, for retirement funds, and they help administer and manage the plans with us. And they will be on site at ECI on Friday, July 7th, so next week. And there'll be half-hour meetings are available from 9 to noon for employees to discuss their 401k account. So it's a great opportunity to learn how to log in to the account and see how your accounts are structured, both on contributions, ongoing, and the proportions of different accounts and so on. And also, we're continuing our 2023 healthcare premium holiday. So that's still great news. It should be pretty helpful in the pocketbook. Oh, I gotta fix my screen here to get my images. Just gotta download pictures. Yay. Does that work? Can you see the Champlain Valley Fair announcement?
We got it, Ken.
Okay, good. So as I mentioned last week, it's getting to be the fair time, at least for pre-ordering tickets. And typically what we do is each employee can request 2 adult and 2 child admission tickets. So if you're interested, sign up with Melanie in our administrative office. Phone number's there, email's there, or just stop by. And the deadline is July 14th at 3 p.m. The problem is there's a deadline for this to get the request in and get these pre-ordered tickets. So make sure you sign up quickly because we only got a couple weeks left here. And for new employees, we get a Scott Vincent, Isaac Baker, Eric Ziegler, and Eric Welcome. So with that last name, welcome to everybody. Welcome to all the new employees. And I'm looking forward to, I've met a couple of you and looking forward to meeting you all. And I carried this announcement again for the upcoming Lamoille Valley Rail Trail. If you're a mountain biker or any kind of bicyclist person, might be a little challenging on really skinny wheels, but this is the Lamoille Valley Rail Trail across from Swanton to St. Johnsbury. ECI did the take up on the job. Oh, but it must have been 15 or 20 years ago, and have since done some minor work mostly since then. And it's kind of a neat little trail that's obviously going to be flat, but it's also a gravel surface. So if you're interested, kind of let me know. But it'll be Governor Scott will be riding the entire thing, 93 miles one day, and there'll be some sort of transportation and support on the way and back. And you can also break it down into segments. It's on that email or that website there, breaks it down into segments. If you wanted to ride, say, from Cambridge to Morrisville, there'll be a time scheduled and a time taken off and an arrival time and that sort of thing. So it can be broken down into smaller segments. I have a link to the ECI Primary Care Wellness Plan. And then now we have the project of the week. And Ben McKinney, did you want to present, or did you want to control the screen, or you want me to?
Yeah, Ken, I'll share my screen.
Okay, perfect. Go ahead.
Cool. Yeah, I'll just note one thing on the organization. I think that's a good topic. I think we all know that we take a minute The other thing I'll note is I think the water bottle situation is getting kind of out of control, and I think we should all work to police ourselves and drink the bottle and not let it become some trash on our job site.
Yeah,
So
we don't
today
want to be like UVM and have a ban on bottles.
we don't. It's a nice
We wouldn't,
resource
obviously, but
that the company helps us stay hydrated, but we don't want to have it be a source of disorganization and clutter. All right, so today we're going to look at our VTrans Royalton BF project. This is a job we have with VTrans to replace the New England Central Railroad Bridge, number 3501, on the Roxbury subdivision, which carries the NECR over Route 14 in Royalton, Vermont. The existing 26-foot clear span bridge is only 12-foot one above the highway, and it chokes traffic down to a single lane with no signals and a blind approach on each side. Ken had a good picture in the original email. I just wanted to show it a better plan view. I think this is our latest drone data. I don't know if you guys can see that.
nice.
That's
We got
a plan view. So you can see that really aggressive S turn in 14. So I think one of the approaches is 50 miles per hour, and you come into a blind single lane, unsignalized underpass. Probably a lot of you have been under it. It's been an issue and pretty unsafe for, I mean, the railroad was there first, which is why the highway looks so screwed up. Actually the old highway used to go over what's now ECI's improved construction crossing over here. I don't know when it was rerouted, but it's been an issue for, I'm guessing, 100 years or close to it, and it's finally being replaced by VTrans. The NECR is getting a free bridge out of it. This bridge is a high strike risk. Besides being a hazard to motor vehicles, it gets hit a lot. Historically speaking, it's been hit so hard that the outside beams have been, mangled and needed to be replaced, and the tracks have been knocked off alignment. And we actually see it get hit pretty routinely. Since we've been on site, it hasn't gotten hit real hard, but I think we've had, several light strikes in a single day since we've been on site.
Including a mini house or a little, what was that? It was in the news here maybe a month ago about
I think that was on a Sunday. We got the call. I don't think any of us were there. Ken may have gone down and responded to it. I don't remember. But yeah, box trucks, camp, everybody managed to hit it. And then once you get into that situation for a trailer, it's hard for them to get out. So the new bridge is 125 feet long. And it's on alignment, on the railroad alignment. It'll go just south of the existing bridge, and Route 14 will be realigned to go under it it'll still have a slight S to it, but it'll be much less aggressive, 2 full lanes. I don't remember, I think it's 14 feet, no overhead restrictions. To do that, the tracks end up coming way up in the end, which is part of our scope, which is why we're widening the slope so much. But today, we're going to focus on the bridge and really the substructure of that bridge itself. So this 125-foot long new bridge will sit on precast cap beams. So the abutment on each side is just a big, long, deep beam, which itself is supported by a drilled shaft foundation. So this bridge has to be built in just 3 relatively short railroad closures. And these 4 drilled shafts, 2 on each side, which support these big beams, those are key to this accelerated construction, because we can get these drilled shafts in. They sit almost outside the embankments. We have some sheets to get them tighter. But those are key to this accelerated construction, because these drilled shafts, which are supporting, the whole new bridge, are now installed, and we're able to be installed with no closures or interruptions to rail traffic at all. So you can see on my screen here, this is kind of a 45 or so degree angle from that drone data. So you can see the existing bridge, and you can see in blue the approximate location of these 4 drilled shafts that got installed. The idea being that during some shutdowns in the future, we'll dig down, find these things, set the caps, bury it back over, get trains back running again, dig it back out, put some more precast in, bury it, get trains running again, and then ultimately dig the whole thing out, put the new bridge in, realign the road.
And lift the tracks too.
And lift the track substantially. The way V-Trans designed it, you do a 3-foot track lift over 1,000 feet in one of the shutdowns. We've got a different idea that we're working on, but more on that later. So we contracted with Hub Foundation out of Chelmsford, Mass, to install the shafts. Hub is responsible for all the drilling, and generally installation of the shaft itself and placing the concrete, while ECI owns construction of the work platforms, the SOE, these big retaining walls, these engineered retaining walls, keeping these big tall work platforms out of the highway. We got lift support, we own anchor bolts, rebar cages, stuff like that. So despite being a subcontract, we had anywhere from 2 to 6 guys involved in the operation on a daily basis. We designed the sheets and these engineered block walls all in-house as usual. Here's a snip from our engineered design. This doesn't show the sheets, but it shows these big platforms to get that big drill rig up to cutoff grade of the shaft, but able to work outside the train window. You can see this ARIMA clearance envelope, so you can see we're working very close to the trains, but still off track, so we can let the 4+ trains a day go through. Each drilled shaft is comprised of a 1-inch thick by 64-inch OD permanent steel casing, which was drilled through anywhere from 14 to 24 feet of soil. The bedrock on this job site's sloping, super variable, which that's why the distance through over varied on each shaft. But the design required a 10-foot rock socket. So whatever soil you found still needed to go 10 feet into rock. So Hub used a Liebherr LB45 to drill the shafts. This is a big rig, weighs 260,000 pounds, fully assembled with a big footprint, moves in several loads. It doesn't move with the tracks. It doesn't move with the mast or the counterweight. So these big platforms were subject to some pretty major surcharges. It was a challenge, especially for the 8-foot tall block wall. So that rig uses a Kelly bar. It's a Kelly bar rig, which is a telescopic bar raised and lowered by a hoist and rotated by an external ring gear. So that you can see it. So that's the mast, which is a hydraulic articulating mast. And then that's the Kelly bar. So that thing will scope out so they can drill deep in the ground with that Kelly bar. There's many segments within it, and it's got, essentially cogs on the outside of it. And that rotator table down there is attached to the mast and has multiple degrees of freedom for, plumb and different angles. I mean, these were plumb, but if the rig's off a little bit, and it's rotated by that ring gear. So it's driven on the outside of the large diameter, and they can unlock it and scope down as they go in.
Ben, are you able to zoom in a little bit? Because it's only a portion of my screen anyway. I assume others.
I'm zoomed in to 180. Let's see.
Yep.
I'll take it up a little bit. It's filling my whole screen. Try 210. How's that? Is that any better?
Well, just thinking here. There. Yeah, that's better. Yep. It seems better, I guess.
So you can see the big rig there with the excavators for support and the crane in the background. Go to 220. So after the casing is advanced through the soil, so they've got some keys in the casing, so they can spin that casing. And often they're alternating between spinning the casing and then grabbing back a hold of the Kelly bar itself and drilling down within it. So just like when we do smaller drilled shafts, it's often a combination of rotating and crowding that casing and then reattaching to the drill string inside, typically with a soil bucket. They've got a lot of different tooling, big, obviously huge diameter tooling. Drilling inside it, maybe even beyond the casing to get through some harder stuff, and then back onto the casing and advancing. So I don't know if it's really technically duplex drilling, but it's sort of a duplex drilling method, I think. So that's a 64-inch diameter outside casing, and then within that it's a slightly smaller 56-inch diameter rock socket. So once the casing hits rock, and I don't remember exactly what it was, but it needs to toe into rock in good shape, and then a 10-foot 56-inch diameter rock socket is drilled down below that. Pretty hard rock on this job, and it was weathered at the top, but pretty hard rock. But Hub was successful in drilling those rock sockets, those 10-foot deep rock sockets, by alternating with a core barrel, 56-inch core, to unconfine that rock and then chewing up that rock with a rock auger, with a rock bucket. We were a little anxious about this. A lot of contractors would have gone to downhole tooling for such a deep rock socket and hard rock right off the bat, which would be like a pneumatic downhole hammer or cluster drill. But Hub was able to get this done efficiently with lower cost, lower footprint technology, which helped them deliver the project economically. So you can see the rig there, a couple of our support machines. He's drilling in a shaft right now. I guess I shouldn't say that the rotator spins the shaft. They just hook onto it with lugs. It's still the Kelly bar driving the casing itself. But you can see some of the tooling out here. They've got a variety of buckets, which with trap doors, which trap soil, and then just conventional augers. If they're into muck, they need this bucket with the trap door. If they're into competent material, they can just auger, rock augers. I don't know what all this tooling is, but they've got a lot of it for the different conditions they encounter. So after completion of the drilling, a heavy rebar cage with integrated CSL tubes and assembly of 14-foot long by 1.3" diameter anchor rods is set in the casing, and concrete is poured via Tremie method. Those CSL tubes that are attached to the rebar cage, that stands for cross-hole sonic logging, which is a testing method that detects voids or inclusions in the pour. None of this is inspectable. It's a sacrificial casing. It's not really sacrificial. I think it's part of the design. So that stays in. So because these are uninspectable, you can't get in there and you can't see it once it's done. They do the CSL testing that I think it sends ultrasonic waves in between it, and it can pick up on anything that isn't good sound concrete. You can kind of get an idea of how close everything is. Here's the drill next to a shaft on one side. Here's us grabbing the cage. After Amtrak goes by, we'll set it. The casings don't make a perfect seal in most cases with the rock here. So it's paramount that any soil, you can Tremie pour through any amount of water, but it's imperative that the soil be cleaned out. So once the shaft was done and approved and inspected to the extent that they can, mostly just with a weighted tape, that rig's got to get back on it, clean it out one final time, set the cage, cut the cage off, pull everything out, get back on it with the rig, clean it out, and then the pump's rolling up, we're ready to pour. We're setting the cage, we're setting the anchor bolts, we're getting the anchor bolts perfect, all in really short order, because the fear is that when you're getting silt back up into it, that it'll compromise the integrity of the shaft. It's important to have concrete all the way down to the bottom of the rock socket, which makes the final preparation for the pour pretty critical and pretty needing to take place in pretty short order. So once that casing's in and everything's good, we cut the casing with some work windows, so right at cutoff grade, so we can actually get to the cutoff, but also leaving a higher tier for our anchor bolt template support tubes, and then above that leaving these 4 pieces up and leaving the top of the casing up, so a work platform to support the Tremie can be up there. So you can see Scott here welding our anchor bolt assembly tubes once everything's perfect, welding it off so that doesn't move during the pour. Those anchor bolts themselves, those are the epoxy bars you see coming up. Those have just a 1/4" tolerance. So the layout is obviously critical. One of the challenges with this is there's no line of sight between the tubes. So our survey team used carefully calculated radial stakeout to make notches on the top of the tube, which really offsets with a hacksaw. And then when it's game time, pumps on site, we're about ready to rock. we're dropping everything in there and then pulling those offsets in with just traditional ancient survey methods, just stringing a plumb bob to get everything perfect. And obviously, not only do they have a 1/4 inch with themselves, but they've got to be, perfectly in sync with the shaft on the other side. So that big cap sits down perfectly over those anchor bolts. You can see here our final layout with a 6-foot level and plumb bob and a string just before the pour. Our anchor bolt assembly was circular, so it's got a hole cut out in the middle for the tremie pour, and it's circular on the outside, which is nice because once we get things close, we can tack one side and then rotate it and then tack weld the rest of it. So once the concrete tremie pour starts, there's hard line, which goes down, which rests on that work platform and goes down to the bottom, and then just a conventional pump truck hooks up to it and pumps. And during the tremie pour, they'll progressively, typically in between trucks, stop, unhook. With our crane, we'll pull a section of hard line out, drop it back down to rest on the platform, hook back up to it with the pump, and withdraw progressively, section by section, the hard line from the pour as we go. So once the pour starts, all that groundwater comes up. That concrete's heavier, right? So you're maintaining a tremie. So that concrete's coming up in the shaft, pushing the groundwater out of the top. And once all the groundwater comes out and it looks like good concrete's coming out, we keep pumping for 2 or 3 or 4 additional yards of what looks like good concrete to make sure any soil or mixed stuff is out. Any inclusion or any void in there would be picked up by that CSL testing and could be cause for rejection of the work, leading to replacement. I don't even know how we would do that, or substantial rework, coring back down through it. Here we are during a pour. We're using Carroll Concrete. That's their pump. See our crane. I'm scrolling here. It's taking a second. So you can see that pump hooked up to the hard line, which rests on this work platform sitting on the top of the cage with cutoff down there at the top of that window. Here's towards the end of the pour, continuing to pump concrete, so fresh concrete is able to come up and then run through a trench to a washout area that we dig, so we don't have quite so much work ahead of us to get all that concrete away from our work the next day. Due to the Amtrak schedule, it's really actually the freight schedule. The agency was okay with Amtrak going through at 10 with fresh concrete, but they didn't want freight to come through at all for, I think, 48 hours or until a certain strength was met. So we had to pour on Fridays. So a big pour like this on Friday afternoons it was good to get done that week, but it would have been nice not to have to do it on Friday afternoons every time. So at this time, all 4 drill shafts have been completed. CSL testing process on one is ongoing. We've completed a bunch of other work on the job, which we'll cover in the future. At this point, the focus is to remove sheets, those big platforms, and start building some new infrastructure to allow a couple of shutdowns in August when we'll set the cap beams and a bunch of the other substructure elements. Then next year, we'll set the rest of the precast. We'll have a 134-hour shutdown to actually get the rest of the precast and the bridge in, and then which will be concurrent with a longer 28-day closure of 14 to rebuild the highway underneath the new bridge, remove the old bridge, get the tracks up if we don't do it prior. Here's a picture of the CSL testing process where they're dropping that CSL instrument. I wasn't there for any CSL testing. I'm assuming it looks kind of like an inclinometer, like a long tube that gets lowered down and is doing some high-tech supersonic stuff down below, communicating with its counterpart in the adjacent CSL tube.
Wow. Impressive project. Pretty neat stuff. And then for the archives here, we have a photo from the Pittsford Bridge that we did back in 2016 with Hub, and This, we're dropping the cage in. You can't see our crane, but it's dropping the cage in or setting the cage in from into one of the drilled shafts there, and Hub is there watching and monitoring before pour. So very similar work, same subcontractor, and again, pretty neat stuff. All right, well, thank you, Ben, and everyone have a good holiday. And if you're taking Monday off, have a good long weekend too. So happy Independence Day. I'll turn it back to you, Matt.
Thanks, Ken. Thanks, Ben. Thanks, Austin. Good meeting this morning. If you're watching a group setting, please just send me a text message or an email so I can capture attendance. That'd be great. Let's have a safe day. Let's have a great day.
Thanks. Have a good one.
Yeah.